This is lecture 14, Diagonalization of a Matrix Part 2. In that lecture, we discuss with an example how to find the diagonal matrix of any matrix. Now find the model matrix which diagonalize the matrix A, that is the matrix A, and also we have to find the diagonal matrix of A. So here we take an example of 2 by 2 matrix. So first we have to find the eigenvalue, then we find the eigenvector. Then we create the model matrix. So first we find the eigenvalues of that matrix. So we write characteristic equation, that is A minus lambda I determinant is equal to 0. So we write 4 minus lambda 1, 2, 3 minus lambda is equal to 0. Now expand that determinant. So we write 4 minus lambda 3 minus lambda minus 2 is equal to 0. On simplify that equation, we get an quadratic equation, that is lambda square minus 7 lambda plus 10 is equal to 0. And when we find that is what, this is the characteristic equation, and find the root of that equation, we get lambda minus 2 and lambda minus 5 is equal to 0. That is lambda is equal to 2 and 5. So this is what, this is an eigenvalue for the matrix A. Now we find the eigenvector. So eigenvector, you take an eigenvector corresponding to eigenvalue lambda is equal to, says lambda 1 is equal to 2. First we find the eigenvector corresponding to lambda 1 is equal to 2, and we take a eigenvector as a x1. Suppose we take a eigenvector x1 is what, is an eigenvector corresponding to eigenvalue lambda 1 is equal to 2. So we write matrix, that is A minus 2i x1 is equal to 0. Here we substitute the matrix and simplify, we get, that is 4 minus 2, we get 2, 1, 2 and 1. Here just we take x1 and x2, that is an eigenvector. Now at that state, this is what, this is a homogeneous system. So we find the rank of that matrix. So by the help of that first row, to make that row 0, so we apply the operation on R2 minus R1. So here the reduced matrix is 2, 1, 0, 0, x1, x2 is equal to 0. Now the rank of that coefficient matrix is what? This coefficient matrix is what? Is equal to 1, which is less than number of unknown, that is 2. So we can say that system has non-trivial solution. So then we write the equation for that, that is 2x1 1 plus x2 is equal to 0. So here this equation implies 2x1 is equal to minus x2. So let's take x1 is equal to, says we say k, any scalar. So we can say x2 is equal to minus 2k. So the eigenvector is what? x1 is k minus 2k. If we take k as a common, so we write 1 minus 2. So this is an eigenvector corresponding to lambda 1. And similarly, we find the eigenvector says x2 corresponding to lambda 2, that is 5. So we write A minus 5I matrix, that is x2 is equal to 0. Here we get 1 minus 1, 1, 2 minus 2, and says y1, y2. And similarly, this is the homogeneous system. So by the help of that first row, we make that row, we convert it into the echelon form. So we apply the operation on R2, R2 plus 2 time of R1. So we get minus 1, 1, 0, 0, y1, y2, and this is what? Now the rank of that coefficient matrix is 1. So again, which is a number of unknown is 2. Rank of that matrix is what? Coefficient matrix is 1 less than number of unknown. So in the system, this system has trivial solution. Now convert into the equation, that is y1 plus y2 is equal to 0. This implies y1 is equal to y2. So let's take y1 is equal to k, so we can say y2 is also k. So the eigenvector x2 is what? That is y1, y2. This is k, and if we take k as a common, so we write 1, 1. Now this is what? This is an eigenvector corresponding to lambda 2, which is 5. So we can say eigenvalue lambda 1 is equal to 2, and corresponding vector x1 is what? We get 1 and minus 2, and lambda 2, that is in second eigenvalue, and corresponding vector x2 is what? We can say 1, 1. So this is eigenvalue, and this is corresponding eigenvectors. Now we write the model matrix. So what is a model matrix? If you remember, model matrix is what? Is consisting the eigenvector. So the model matrix, that is we say P, is equal to what? It's contain the eigenvectors x1, capital X1, capital X2, or we can say 1, minus 2, 1, 1. So this is what? Model matrix. Now for that model matrix, now we find the inverse of that matrix, and all of you I think know the how to find the inverse. So P inverse, you can use any method to find the inverse, adjoint method, or you also use the method normal form method. So we get our inverse of that matrix is 1 by 3 and 1, 2, minus 1, 1. You can use any method to find that inverse. So this is a model matrix, and this is what? Inverse of model matrix. So now we find the model matrix and the inverse of model matrix. Now what is the diagonalization for the? This is the model matrix. Now the diagonalization is what? Is D is equal to P inverse the original matrix into P. So we write 1 by 3, 1, 2, minus 1, 1. Then we write the matrix 4, 2, 1, 3, and the model matrix 1, minus 2, 1, 1. Now you just multiply this matrix. And what is that? First we multiply these two, 1, minus 1, 2, 1. So we get what? 4 into 1, 4, minus 2, we get 2, 4 plus 1, we 4 into this 4, and 1 into 1 plus 1, that is we get 5, 2 into 1, 2, and 3 into minus 2, we get minus 6, so we get minus 4, and 2 plus 3, we get 5. Now we multiply these two, so we get 1 by 3, and when we multiply this, to 1 into 2 minus into minus 4 we get plus 4, so we get 6. 5 minus 5 we get 0. 2 into 2 4, and minus 4 we get 0. 10 plus 5 we get 15. Now this 1 by 3 we multiply inside, we get 2005. So this D is what? We get 2005. So this is what? This is a diagonal matrix, and this is a diagonal matrix of given matrix A. So this is all process. First we find the model matrix, then by the help of that model matrix we find the diagonal matrix, and for model matrix we have to find the eigenvalue and eigenvector, because eigenvector model matrix is found by the eigenvectors. Thank you.